Welcome to another episode of The Impact of AI, sponsored by AI Time Journal. Each week, we explore how AI and cognitive technologies impact us daily, both professionally and personally. For those of you whom I've not met, my name is Melissa Drew, and I will be your host for this week's podcast. We are really excited. This is going to be quite fascinating because today we have Mai Aye. She's from Cardinal Health, and she works in this newly developed business group called the Fuse Innovation Lab. And it's their mission to develop AI-driven solutions for healthcare. Now, she works in this group as a senior machine learning architect. Hi, how are you doing today?
Hi, how are you doing? Thanks for having me, Melissa.
This is going to be great because we've had a lot of questions a lot lately around the difference between a data scientist and a machine learning architect. And I think you're going to be able to provide a lot more perspectives and enlighten us on what the differences are and really the role, which I think, in talking to you earlier, your role as an architect, I think, is very important within the larger picture.
Yeah. Right.
So first question we always ask everybody is we recognize that nobody's journey is ever straight and narrow. And I noticed on your LinkedIn page that you originally started in political science before you then shifted into management information systems and analytics to where you are today. So I'm curious to go all the way back to the beginning and understand what interests you about political science, but what caused you to shift?
So I actually went to a K-12 school system that was big on liberal arts and the classics. And my father made sure that, I was reading stuff like Shakespeare, Plato's Republic, and a lot of work by Aristotle by the time I was in middle school. So I've always been interested in the social science and the liberal arts. I wasn't really a science person starting out. So I took this road less traveled towards data science and machine learning, and this sort of circuitous and difficult path, pretty much gave me a well-balanced education, obviously with a strong foundation in the liberal arts. So I got my bachelor's in political science and French from UC Berkeley, and thinking that, I would be a lawyer doing international law someday. And my master degree, and I went back to Carnegie Mellon to get my master's in information systems. And I graduated into the great recession of our generation, where new jobs were pretty much non-existent for new graduates. And I started working at a law firm. I was trying to test out to see whether the legal career was a good choice for me. And while working in the legal industry, I actually regularly use NLP software to help lawyers quickly discover relevant documents among thousands and thousands of evidence material submitted during discovery and trial preparation phases. So I saw firsthand how data and technology made a huge difference in saving cost and even improving our clients' cases. So I pretty much then found my calling in technology and data, and I actually took computer science and math classes at night while having a full-time job to actually prepare for a technical education in graduate school. So after I got admitted to Carnegie Mellon for graduate school, and then I finished graduate school, and I actually landed my first full-time job as a data scientist at IBM. And at IBM, I was actually involved in many different data science initiatives, right? From doing data analysis, building and operationalizing models, to leading small teams and even doing bids and proposals on the side. And data science at IBM was definitely a lot of fun. I built and operationalized a lot of the anomaly detection models that identify and prevent healthcare fraud and patient harm. And my favorite project so far was an NLP project where we actually built and operationalized NLP models that classify text and extract relevant information from large amount of documents, right, to automate claim processing and improve the overall patient experience. And at the beginning of this year, I joined Cardinal Health as a senior machine learning architect.
Mhm.
So I feel like if there's one thing that, gave me a boost and truly differentiated me throughout my data science journey, would obviously be my liberal arts education, thanks to my father, who made me read Shakespeare and Plato at 13. And, conventional wisdom in the tech industry says that, oh, liberal arts education is useless. What are you going to do with those artsy fartsy majors, right? But then it taught me, it taught me very important skills like how to combine disparate viewpoints into a well thought out insight, right? Make recommendation and even turn that into a unique idea for product development, right? How to communicate and write effectively and ask good questions, and how to look at the big picture and develop empathy and even recognize, higher order consequences, not of a decision, right?
And
Not
I'm
just
sorry, you learned all this from your liberal arts degree?
yes, we had to do
Wow.
research.
Wow,
And
I
then
think you're the first person who's ever been able to truly tie the results of a liberal arts degree into something that they're doing today. Like, that's fantastic.
yeah, so we had to do research in political science, to see the short term and the long term impacts of colonialism, right? AKA like the higher order consequences, right?
Yeah.
And I was technically a philosophy major under while I was studying French. We had to read a lot of ancient texts by French philosophers like Montaigne, right? And they like teach you how to look at the big picture and see things from a meta perspective, right? So that really helped, in terms of seeing the big picture and really recognizing the high order consequences of a decision. So when you're built, so as a machine learning architect, understanding the higher consequences, right, of a system you've built, not just adding, like shortcuts, short-term solution. It's something I got from my French philosophy degree. And most importantly, it taught me how to check my assumptions, right? And always think deeply with a lot of intellectual rigor and honesty.
Yeah.
Right. And it also kind of trained my mind to always be naturally curious, and I can learn new concepts very quickly. And it also forced me to even unlearn a lot of my prior habits and thoughts that may no longer work. So I guess, in this day and age, a lot of companies are trying to create this responsible AI and formulating different products to go to market quickly, and even quicker than their competitors. So I really believe that, technical skills married with the liberal arts are becoming more and more relevant as ever. So for all the English major, political science major, psychology major out there, if somebody makes fun of you, don't get discouraged. Your viewpoints and your skills do matter, especially in the world of AI.
No, that's awesome. Like I said, I think you're going to be the huge advocate poster child for the liberal arts degree. Awesome.
Right.
Let's shift that now to what you do today. You are the senior machine learning architect within this innovation lab. But yet I also hear the term data scientist. I hear the word engineer. I see the word architect next to your title. Are those all kind of the same, or is there really a differentiation between those?
Okay, that's a good question, because the term data science, machine learning architecture, and engineer are very vague across different companies.
Okay.
But then there are differences in those roles. So when somebody says data science, right, that usually means that the data scientist is mostly involved in extracting insights and even from the data itself and making recommendations, right, to the business owner to drive the overall product or business strategy.
Okay.
Right? That's the classical definition of what a data scientist is. And sometimes data scientists will actually build machine learning models, right? If machine learning models are what makes sense for the business, right? And then there's the machine learning architecture roles and machine learning engineering roles, and they mostly spend their time on the operationalizing the models, right?
Mhm.
Either the prescriptive or the predictive models that the data scientists build, right? So the machine learning architects are the one who build these data ingestion and these pipelines that take these models into production, right? So the end users, can have these model results on a consistent basis to make informed decision, right? But here at Fuse, I have to do, I'm actually doing both. Sometimes I spend a little bit of time on the data science side doing analysis, right? To look at the outliers, to look at the trends, right? To explore different methods, right? And then I would take the model that we've built into production by using existing pipeline or even building a new or better pipeline. So our end users, can have these model results on a daily and consistent basis
Mhm.
for their own business operations.
You have a blog that is out there.
Yeah, I have my Medium blog. I just wrote one article on NLP.
I
Manual
actually read
content.
that.
Yeah.
So that's how I know you have a blog is I read it and you went really deep, which I thought was fantastic around the different techniques of clustering.
Mm-hmm.
So if we take that, the content of your blog, and we look at what we just talked about, the data scientist is out there working with the stakeholder, working with their requirements, understanding what they're looking for, drafting that initial model, understanding, the context of that model and how that the impact of that model. And then what you're doing is you're taking what they've created in this kind of proof of concept or this prototype, and
Mm-hmm.
you're using these other techniques, which I believe clustering is one of them, to take this from prototype and scale it into production.
Right.
Okay.
Right.
Okay.
Yeah. So machine learning architects or machine learning engineers are the one that takes the data scientist models, right? Either they could be prescriptive models that contain just metrics or a predictive machine learning model, right? And then serve that to the wider world. It's kind of like iPhone versus AT&T, right? Apple manufactures the iPhone and AT&T pretty much distributes it. Let's think of it that way.
I like that. It's a good
I just
example.
think with the technology, yeah.
Yeah, that'll resonate with everybody. Everybody's got some kind of mobile phone. Yeah. So, as you start to look at how you're operationalizing your models and moving them into production, what are some of the key considerations that you think of?
So the first key consideration is making sure that the pipeline that we're building to operationalize our models is what's appropriate for the user and our business outcome in mind, right? So in our case, we want to send our users, our end users, right, our model results and the data that they need to make decisions on consistently, like reliably on a daily basis, right? So the pipeline that we built have to ensure both good data quality, right? Good model prediction results, and it also has to have velocity, right? We don't want to build a pipeline that sends you, very good data quality, right? Very good prediction results, but then you have to wait a week, right, to get them. So we kind of have to learn how to make those trade-off, right? Like everything in life, architecture is making trade-offs, right? That's appropriate for our end users. So with the pipeline that we've built for our projects, right? We have a pre-ingestion check, right? Where we do data quality checks for the data coming into our pipeline, right? And then we also do the same quality checks on our prediction results, right? And then we also do a post ingestion checks. And basically, if they don't pass these quality checks, right, then we build this human in the loop functionality as well. So if the model results and the data quality fail the pre-ingestion and the post-ingestion check, right, our data scientist and data engineer will get an alert saying, hey, your model results and your data quality don't pass the checks, right? Please look into it immediately, right? Before we send the results over to our users. So, building a resilient pipeline that works for our user is what's important to us as machine learning architects.
And I'm guessing, just listening to this, that what you've explained to me is just a small component of the larger picture. Like, I think you've really articulated that there's a lot that you have to balance and a lot that you're considering, but just in the last couple of minutes, you've only been able to touch on just a small percentage of everything else that needs to happen.
Yeah. So if we look at things at a meta level, it's about achieving the right trade-offs, right? When it comes to quality and speed, that works for our business and users.
Right. Yeah. I think about a month ago, you and I had connected and we were sharing, what books we were reading. And you had mentioned a book that I wrote down, and it's called Antifragile: Things That Gain from Disorder. And I did go look up the book, and I read, just kind of skimmed through it. I didn't read it all, but I did skim through it. But I thought what was interesting is in your perception of the book and how you're taking what you're learning from the book and really thinking differently about your job.
Okay, so I read Nassim Taleb's on Antifragile, Things Like Disorder, about 2 years ago when I was working at IBM, and I wasn't really a machine learning architect back then. I was more on the data science side. But that book really opened my eyes, as a data scientist and a machine learning architect with a very unconventional career path. So according to Nassim Taleb, anti-fragility in people and in systems that we've built, right, is basically the ability to improve and grow from shocks, chaos, and disorder, right? It's an entirely different concept from resilience, right? Especially the resilience pipeline that I just described.
Right.
So like the Buddhist concept nirvana, anti-fragility could sometimes be a very nebulous concept, right? That's hard to achieve. So I feel like we can move like closer to it, right? Instead of trying to fully get there, right? So the first steps, I feel like, for moving towards anti-fragility basically involve building, decentralized and decoupled systems with little to no interdependencies, right? And sometimes even introduce chaos and black swan events into our existing systems as tests for evaluation, right? So as a machine learning architect, I've always wanted to explore different methods for our data and machine learning pipelines to evolve from this traditional resilient model, right, into something that's more that's closer to anti-fragility, right? So in the future, we can have self-learning we can have machine learning systems that pretty much learn on their own, right, and evolve without with little to no human interventions. I know that sounds kind of scary. Right?
You paused right before you said that.
that sounds scary. But as an architect, right, we want to build systems that simulate the world, right? And the world is naturally chaotic, right? From a lot of shocks. So when I was taking distributed systems back in Carnegie Mellon, the architectural and system design pattern we've learned revolve around this concept of resilience, right? So Nassim Taleb's book Anti-Fragility really opened my mind on how to build a different kind of systems that actually benefit from shock, chaos, and disorder.
Right? So the concept is that through unstructured, through and I don't want to use the word chaos, although I understand what you're saying, but the idea is that through this messy component that we'll get to an end result, but the end result would be much more favorable than if we had a very structured approach to that outcome. Is that
Definitely.
so? That
right.
kind of what we talked about with your journey, the indirect path
Yeah.
allows you to be better at your job now than if you knew straight from the beginning that you were just going to go from A to B.
Definitely.
Okay.
Right?
Okay.
So embrace the messiness and the chaos, right? And learn
Yeah.
to build anti-fragile systems from that. And I think, you know, the like embedding anti-fragility into machine learning system, that could be an entire PhD thesis in itself. If I can go back to school and, you know, do my PhD in computer science or
Yeah.
machine learning, right? But there are specific approach that we can take to move towards anti-fragility, right? The first thing is, you know, building decentralized and decoupled systems, right, that work independently, right? So if one system fail, another system can just take over and
Okay.
still do the job. And another method that I'm thinking is actually introducing outliers, right? Into models, right? Introducing these black swan events, right, into our
Like
data set and
from
into
a data perspective.
from a data perspective,
Right.
and then kind of evaluate, you know, how they perform over time versus machine learning models, you know, that have consistent and stable, stable or uniform representation of data. So you know, I guess on my free time, I'm kind of I wanted to actually explore different methods, you know, to get to anti-fragility, right? Because
Yeah. So I was thinking, when you talked about data, so usually when we look at data, we think of the bell curve, you know, and when you were talking about outliers, I was envisioning that at the moment we're trying to absorb as much data as we can within the column of the center of that bell curve. So when you reference the word outliers, are you talking about making sure that we get all the data? Because those outliers, even though they're 3% on the one side and 3% on the other side, that's still going to have an impact, probably more so than if we just pulled the data from the center of that bell curve. Is that?
Yeah, definitely. I mean, outliers are black swan events that have implications, right? And in data science, you know, we spend a lot of time, you know, looking at outliers to see if they make sense for our models, right? What are the implications of removing these outliers and building models without them, right? So I guess, you know, I'm more on the crazier side because my approach is to build a model with outliers, right? Let's just accept them, right? And embrace them, right?
Yeah.
You see what they do over time, right? As we operationalize them, and then compare that with another model in production, right?
Well,
And
I
see
think you make a lot of sense.
yeah.
I did.
See their performance, right? And that's how
Yeah.
you move towards some anti-fragility, right?
Well, I think you make a lot of sense because when I'm out in the field, at least up until, you know, recently, we were always the 80-20 rule. Go spend, you know, a majority of your time building what is going to impact the internal stakeholder 80%. Don't worry about the other 20% because you're going to have to spend a whole much more time just to get that 20%. But when we're in the depths of talking to the stakeholders about the processes that impact them, it's all the processes and it's all the data that impact them, including these outliers, you know, the remaining 20%. So I think it's absolutely on point to reference that, you know, maybe in the past we were all focused on that 80%, but now that we've got, you know, the AI technologies and the ability to pull the data together, synthesize it, and be able to understand it very quickly, I think it makes more sense that we need to now encompass all of that, including these outliers.
Right. So my rule of thumb is, you know, never ignore the outliers.
Yeah.
Right. And I think I was reading an article, and there was an article that said one of the worst humanitarian and even environmental disasters happen because when the data scientists or the analysts were sampling their data points, you know, to do quality checks, they ignore the outliers, right? And the
Yeah.
outliers tend to be those events or phenomena that really drive and create this huge shift, right? Either
Yeah.
in a positive direction or a negative direction for that impact, a lot of people.
Yeah. The when we look at supply chain and procurement, it's those
Mm-hmm.
outliers that don't come very often, but when they come, they're the ones that hit the organization and the economy the hardest. They're the ones that have the largest disruption.
Mm-hmm.
And because nobody looked at those outliers, nobody could predict it was there. Nobody knew it was coming until it was too late. So I'm all on board. I love your idea. I think
Mm-hmm.
it's absolutely the right way to go. If not everybody's doing it, then for those of you listening, maybe this is something you should consider. Yeah.
Right. Yeah. And the second book I want to talk about,
Yeah.
that I think everybody should read, is called The Swerve: How the
Swerve.
World Became Modern by
Say
Stephen
that
Greenblatt.
again.
A Swerve: How the World Became Modern by Stephen Greenblatt.
Okay.
So in that book, Greenblatt actually tells us, the story of this obsessive book collector named Poggio Bracciolini in 15th century Italy.
Mm-hmm.
And he actually discovered the last copy of this ancient poem called On the Nature of Things by the Roman poet Lucretius in this, neglected monastery, right? And every time I talk to my cousins in high school about this Roman poet called Lucretius, they always thought, is that a rapper? I'm like, no, it's not a rapper.
Love
It's
it.
a poet who wrote this really long poem called On the Natures of Things, right? And this discovery by Bracciolini, the Italian book collector,
Mm-hmm.
um, pretty much, like reintroduced the once but lost and very important ideas, about science, right? About life and religion to medieval Europe. And it sparked, all these intellectual and philosophical movements that made us more scientific and more modern, right? And so as someone, who's in a technical field where innovation is crucial, I think this book had a huge impact on me because it actually taught me that, disruption happens through this like cross-pollination of different ideas, right?
Mm-hmm.
From the most unlikely places, right? And Bracciolini definitely, taught me that, we gotta be like always obsessive. We gotta be like kind of become obsessive collectors and curators, right, of innovative and even crazy ideas, no matter where they're from, to build groundbreaking products that can move, certain industries like healthcare forward. So it's a very good book. Check it out. It was, I think he won the Pulitzer Prize for that, Stephen Greenblatt. And it's very inspiring, and it's very inspiring as well. So
I wrote it down. So thank you. As we look, circling back to your role as an architect, if there's folks listening that are in the data scientist or they're going to school in computer science or machine learning or data science, I mean, there's a lot of degrees and certifications out there nowadays. What are some things that you can pass on to them?
I was going to say learn programming and be well versed in machine learning algorithm, learn to code, I don't know, logistic regression or decision tree from scratch. I was going to give like a very, dry technical advice, but but after working in this field for many years, my advice would be to develop empathy
Mm-hmm.
for the users who are going to be consuming your model results, right? Because if nobody can understand what you've built and how to use it, right, then there's really, no point, right? And the first challenge we've always faced as new data scientists and even machine learning architect is, context and problem definition, right? Sometimes stakeholders, on the business side could have different understanding of, what problem we're trying to solve by building a model, right? Mm-hmm. On the other end, like us data scientists just want to jump straight into the fanciest, technical solution. So this dynamic, could easily become a tug of war that gives everyone a headache. So to bridge this gap, I would recommend a lot of data scientists, especially the new one, to actually invest time up front, sitting down with the stakeholders, defining what the problem that they're trying to solve, right?
Mhm.
Defining the value of the model that they're trying to build, and even its feasibility. And if they could, even educating these business stakeholders on data science, right? So kind of be ready to be an evangelist, basically. Right. And the second advice that I would give them when it comes to empathy is involve defining metrics and key outcome measures that are useful to the business problem at hand, right? So a lead data scientist I used to work with always says, there's statistical significance, and then there's practical or business significance.
Mhm.
So good metrics, that are useful to the business are not always straightforward to develop. In school, the data set that they gave us are clean, right? And we can just build a model and be done with it. We didn't have to deal with different stakeholders. But in the real world, good metrics, especially useful metrics, are not that straightforward to develop. And as data scientists and machine learning architects, especially the new one who spent a lot of time coding and have this tendency to always jump into designing the fanciest solution, right?
Mhm.
I feel like we have to be always ready to articulate persuasively to our business stakeholders why our metrics make sense, why they're useful to them in decision making, right? So overall, I've learned that business outcome should be the utmost priority during model or metric development, right?
Mhm.
And sometimes a successful business outcome entails just building a simple KPI, right? Based on good old fashioned statistics and business acumen. And sometimes, it may require a fancy machine learning algorithm. So my overall advice would be, to really develop empathy for the end users who are going to be consuming your data science insights or your machine learning models, right? And make sure that a successful business outcome is your utmost priority in your data science initiatives.
I think that's really insightful,
Mhm.
especially, you've been there, you've done this. I like the fact that you were, at first you said, well, I could give you, you need to go learn this, this, and this. But in reality, because I've lived it, this is what you really need to know. And that's exactly what we need from folks like you.
Mhm.
The ones that are in there doing the job, but they're willing to share the information of, here's my lessons learned, here's what's really important, here's what's really impactful. So yeah, I appreciate it. As we start to wrap up our time, I would like to know from you, in your role as this machine learning architect, what is it that really excites you? What is it about what you do on a day-to-day basis that is what excites you to get up every day and do it again?
Oh, okay, yeah. So you might have heard this from a lot of people, and it's gonna sound trite, but I do really enjoy working in the healthcare fields and then
Uh-huh.
use machine learning and data science to improve patient outcome. I know it sounds trite, and a lot of people probably heard this from different people, but I'm just not saying this, to be polite or to sound politically correct. I really mean this from the bottom of my heart. Um, and currently, at Fuse, I'm on this project for value-based care where we've built this data-driven cost tracking solution called Episode Analytics.
Mhm.
So oncologists and administrator could use it to basically accurately measure the cost of care, right, at the start and during the entire episode of care, right?
Mhm.
And this allows them to make more informed treatment decisions and give them clear insights into their value-based care performance. So we've actually developed this tool because we know oncologists are highly skilled in treating their cancer patients, but they don't often have the appropriate tool to keep track of and assess the cost of each cancer treatment
Mm.
and their cost performance against the cost targets set by Medicare and Medicaid, right? So this solution is extremely impactful because it not only helps oncologists keep track of their patient treatment, but also shows them the prediction on how much it will cost them for that episode of care, right? So as a machine learning architect, I have a lot of fun on this project because I was directly involved in, building and operationalizing this real-time data and machine learning pipeline that ingest millions of claims and remit and patients data, right, from disparate sources, and then serve this model prediction results, right, predictive cost to our end users on a daily and weekly basis.
No, that's awesome. Because what I hear when you talk, because you're so passionate about it, is you're really making a difference. Like, I don't know how many people can go to work and say, I know that what I did today is specifically making a difference in someone's life. And that's awesome. That's really awesome. I don't know a lot of people that could say that about their jobs.
Thank you.
All right. Well, thank you again for your time. I knew this was going to be really fantastic. It was absolutely enjoy talking to you. Bye.
Bye.